1, 2. Welcome to possibly the last lectures of the course. Because next week, well, next week is not the last week, right? Next week is the last week. Next week is not the last week. The week after that is the last week of the lecture of this class. Okay, so, but this will be potentially the last lecture of the course, right? Next week you're gonna have on Tuesday it will be a Markup Pushar day, right? So it's basically no class, right? There will be no class on it. On Wednesday, there will be a guest lecture, right? So that is about next week. Also next week, in case you are not aware, next week we're gonna have check out for SP4. I'm not sure whether you're aware or not, but it's pretty quick, right? But well, I can tell you that the checkout for SP4 will be very, very relaxing. Okay, if you do SP4 by yourself. The week after that, the week after the next week, we will have a lab on transactions. On Tuesday, P1 will host a lab. And on Wednesday, there will be project presentations. Yay! Woo! Okay. No one looks excited about it. Sad. Anyway, so today's topic, basically the last topics. So far, each lecture that I'm trying to teach you like a technique to make data management better, more effective, like data persistence, data organizations, data catching, data models, query language, data redundancies. What else? Last week, concurrency control, and today's lectures. All of these. Well, good news is that all of these features are in most database management systems. And that should be the reason why. If you want to manage data, you should use well-crafted database management systems that they offer all of these features to you. Okay, data organization, a good data organizations, data persistence, data catching, concurrency control, also in this lecture as well, right? So I'm like a salesman trying to sell that, hey, we have DBMS, so if you want to manage data, just use this. They have like fancy query languages. You don't need to write a very difficult Python anymore. You just need to write SQL to retrieve data from your database management systems, right? I mean, that actually the essence of this course, right? It teaches you what is the meanings of database management system. If you know, at this stage, if you know what is database management system and you know the features, that's it. I think you're good to go. Okay. Yeah, next week on Wednesday, we're gonna have like guest lecture from DBP, right? She was the one who will give feedbacks to you on the last semester hackathon. I'm still asking her whether what's gonna be her topics. So she said that she would like to, she is now generating the topic using Gemini so that the topics looks fancy. I mean the context she has not generated it, but she wanted the topics to be, you know, appealing, fancy. Yeah. But there will be a participation bonus in case that you participate in her activities. She said that she's gonna make some activities for you. She's gonna let you do some things. So if you participate either in her activities or ask the questions, answer her questions, there will be 2% up to 2% participation bonus. So I do something like this. 1% per participation. A very good free scores here, right? So team projects, in case that you are not aware about it. So yesterday it was a deadline for the halfway check-in. I hope all of you have done the check-in already. And I hope everyone submit the check-in submissions on the form that I post on the forum. If you haven't done that, you can still do it, okay? In case you have checked in with our TA or your project advisor before. If you have done that, then just submit. If you forgot to submit yesterday, just submit it today, okay? I don't mind that much. Okay, but the week after the next week, you're gonna have a project presentations on March 11th. And that's basically you need to wrap all the things up. Basically, you need to done implementing the project. Okay. I want to see 3-minute demonstrations of your project. You need to do not live demo. You need to demonstrate your applications. The trick is that you don't need to do live demo. Live demo, mostly you likely gonna encounter you may encounter some issues. So my suggestion is, even though you can do live demo if you want to, you can just record the video of you demonstrated and then show it to your friends. That's fine as well, right? So either way, if you want to do live demo, I'm not restricting you from doing that, but my suggestion is just record a video of you demonstrating it beforehand and open the video, okay? Also, it's a presentation. It's not like a video showreel, a showcase, right? So, last time when you do project proposal, your friends are not in this room, right? We and some TAs only watch you, listen to you, your proposals. But this time, since this is project presentations, so you will be presenting your presentation, the demo to your friends. So everyone should be in this room. Must be in this room unless you have a very urgent issues, okay? So, which means you should reiterate your motivation. Why do you do this and the problems that you're trying to solve with the application that you're making, okay? I expect the presentation to be within 5 minutes, including the demo, right? We may ask some questions as well. And this time, the questions may not be only to clarify your presentation. Unlike proposal, the question is for us to clarify whether we are on the same page with you or not. But for the final project presentations, we're gonna ask, it is like the hackathon. It's basically the hackathon, the same presentation style as a hackathon, right? It could be unseen judges as well. I'm inviting some to be here. You may not have seen them before. If they can join us, then they will join. If not, then you're gonna see only us. Basically, since it will happen on Wednesday, so potentially you're gonna see me and some TAs who are available on Wednesday. Right? Any questions, comments, concerns regarding the project proposal presentations? Final project presentations. Well, once you've done the project presentations, then study for the final exam. And after the final exam, you still need to submit a report. Right? report in the code. So I just want, I will give you the format of the report. Just write it down, okay? It's not just write it down, but try to make it, try to do your best, right? Questions, comment, concerns? No, good, wonderful, awesome, splendid. Okay, so SP4 due is due next Wednesday because next Tuesday is a holiday. So we're not gonna have any class or any details on that day. So it's gonna do on Wednesday. But the checkout will be available for you since starting from Monday to Friday again. So you can make an appointment. I think people will release the big queue slots this weekend. So yeah, but again, just to claim it down, the checkout for SP4 will be relaxing if you do the assignment by yourself. Okay. If not, then you're gonna run into some chaotic questions again. Alright, so let's get into the lecture. So the lecture is gonna be pretty quick. So first, before we get into the lectures, I would like to talk about this one, checkpointing. Checkpointing is some features. These are features in most database management systems that offers transactions. So last week we talked about transactions, right, which is a sequence of read and write operations. Basically, transaction is like you're trying to execute multiple queries in order to do a single action, right? For example, a money transfer could consist of multiple queries, right? And you pack a set of queries together as a transaction by putting a begin transaction on before the first queries, putting commit before the last queries, right? And once you put begins and commit, then in between it, if your DBMS database management system is good enough, they implement some concurrency control protocols, then you're going to ensure that the result of the execution, given that we have multiple transactions, will always be the same as it being executed sequentially, or it's being executed as a serial series. So that is about last week. So if you forgot about it, wait. Okay. So if today we have time, I may go through some questions in the practice exam, so that you know how should you answer. Okay. So rather than that, data objects, typically when you read some data from database management system, let's say you select something from the database management system. If you remember, we talked about data caching before. Many database management systems also do caching. They cache the result, not the result. They cache the data that they read from the disk and put into memories. Right? They do that in caching, like the LRU things that we talked about before. Right? So those data objects are cached into the area that we call buffer pool. Buffer pool here is the main memories, right? Normally your data will be on disk because it needs to be persistent, right? See, everything is now linked right now. So data objects are normally on disk, but once they are in use by many people, then they will get cached into the place called buffer pool, which is basically the memories, the main memories, the DRAM things, which is faster than disk, right? But the problem is that, let's say those data are hot, right? And you keep updating the data on that cache, on that memory. So when the power, let's say, is off, or the failures happen, the DBMS crashes. Values that you update on the buffer pool or on the cache will be gone. And that somehow is unacceptable, right? Let's say you are trying to transfer money. you update your balance, and then computer crash. And now, right after that, you found out, hey, your balance didn't get deducted. Oh, it may seem good for you as users, right? But for banks, they're not gonna be in a good situation, okay? So occasionally, in some periods of time, maybe every 10 minutes, every 5 minutes, every hours, you flush the data on the cache in the buffer pool back to the disk in order to ensure that, hey, those data are now at least get saved on the disk periodically. But still, if the crash happened during that time, after we save, we flush, something bad could happen, right? The moment we do the flushing, we call that we are performing a checkpoint. We are making a checkpoint. The checkpoint, once we make a checkpoint, all data on cache must be flushed back on the disk. That is the meaning of our checkpoint in the DBMS. And you can also do checkpoint by yourself. There will be some DBMS expose a command for you to manually do the checkpoint, like .db. In .db you can also write the command checkpoint. But let me just open it to you. So once you write checkpoint here, all the things on cache will be backed on this at the moment. You manually force everything on cache to be back on this. Which means if you would like to ensure that your data is like on this almost every single time, you should do a checkpoint very often. But well, if you need to do it this manually, then how are you gonna be sure that this system is reliable, right? I mean, sometimes you could make some human errors, forgot to do checkpointing, and your data lost. When you lose your data, this system shouldn't be used, right? So that's why, even though we have checkpointing, but database management is typically trying to help you ensure that even though you don't do checkpoint, you can still do something to ensure that data are persistent on this, or logically persistent on this. So that is why we're going to talk about these terms: asset properties of transactions. Acid, A-C-I-D. We are not in the chemistry class, so don't be worried about it, right? I'm not good at chemistry as well. That's why I'm in computer science. Right? Why do we need to talk about this acid properties? Most database management systems, they try to make sure that if you do transactions, if you write all the queries, all the action as a transactions, then you are likely gonna have these properties in most DBMS. Okay. The first one is atomic cities. I think I have introduced this to you last week a little bit, but let's talk about it more. Right? Atomic city means that all the transactions in the transaction we have multiple steps, right? If database management ensure that all transactions must be atomic, or all transaction has the atomic city properties, then all the transactions must be, all the steps in a transaction must be all done, or not things are done, which means it can be halfway done. When you transfer your money, let's say first you read the balance of yourself, right? Okay, now my balance is good. I have sufficient funds. So I'm going to transfer. The first step is I deduct my balance. And then the next step, gonna be I update the destination balance, right? But let's say after the system reads your balance, the system crash. Then when system recover back, your balance get deducted, but the destination balance didn't get updated. So you lost money. You lose the money. You don't want that. You don't want that. So if database management system offers, say that all transactions must be atomic, or all transactions must have atomic CD properties, then none of the transactions will be halfway done. All of them can be in two states. The first state is we can have only two outcomes when you execute a transaction. The first thing is all the steps must be done. The second one is none of the steps must be done. We're gonna talk about how database management system handle this later. Okay, there must be some things to help facilitating these mechanisms, right? Next one is consistency preservations, or some textbook gonna say that is on consistency. Consistency means that transactions are born upon consistency violations. Whenever the transactions give you somewhat inconsistent values, the transaction will get aborted. When it get aborted, then it will do rollbacking to revert all of things back. Consistency violation. When the violation is going to be made? When the database is not correct. We talked about the correctness of the database before, right? We talked about that. First, database administrators need to define the correctness of the database by putting the types on it, right? By putting the integrity constraints like primary key constraints, foreign key constraints, check constraints, what else? Unique constraint, not null constraints. Those constraints are for making sure that are for dictating the definitions of the correct database. And a good database management system should ensure that once the transaction is done, all data must be consistent or must be correct according to the definitions that database administrators define. Okay, so that is about consistency preservations. In case that, let's say you execute the transactions and transactions somehow meet your balance lower than 0. And you define that, hey, this balance should be less than 0. Somehow transaction must be avoided, must be rolled back. So that is about consistency preservation. This is the hardest one to understand somehow. Many people teach these properties in a lot of ways, but it's nothing. It's just like the data must be correct. That's the main point of these properties. Okay, isolations. Only consistent data visible as if there is only a single user mode. Sounds confused, but it basically that all transactions must be executed as, even though there are multiple transactions are executed concurrently, it must be executed as there is only a single transaction. They must be executed as the schedules is serials. Isolation means the effects of the transaction must be as all transactions are executed in a serial schedule. Basically, it is what we talked last week about concurrency control protocol, right? That we want to ensure that all the transactions are executed. It could be overlapping, sure, but the effects of all the transactions must be executed as they are executed in a serial manner. That is why we say that as if there is only a single user executing transactions. This is isolations. Isolation means you isolate transaction as there are only one of them. Durabilities. Committed efforts or transactions that are committed are failure resilience. Which means if the transactions are committed, it must be resilient to crashes, to power failures, to blah 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 blah. This is durability. I can tell you right away that none of DBMS can ensure these properties, but they try to make sure that most of the times, if not things very bad happens, this will be ensured. Something very bad means the data center get bombed, the data center get flooded, all the machines crashes, the disk get exploded. Those are bad situations. But if the power just fail, most DBMS still help you make sure that all the committed transactions effects must be resilient to that situations. That is why in the real world, in the real situation, to make sure that you are resilient to maybe flooding, or maybe there could be an earthquake here, the data center, the machines fall down from the top of the buildings down, and all the hard disks get broken, all the data are gone. So nowadays, to make sure that we are resilient to that situations, that catastrophe, that disaster, we have something that we call a disaster recovery zone, DR zone. DR zone means that instead of we collect data at a single location, we mirror the data from one location and store it on multiple locations. We call it multiple availability zones. A lot of terms here. Once we can store it in multiple zones, let's say we store one in Bangkok, we store one in Japan, we store one in the States. Let's say Bangkok gets another earthquake, the data center gets crashed. You still have data in Japan, in the States, right? So that is to give you more durability. But no such thing as 100%. Let's say if the Earth exploded, this won't be ensured, right? So that is why there's no such thing as 100% durability. Okay. So as I tell you, isolation, we have done it last week, right? Isolation was done using concurrency control protocols. Two-phase locking, timestamp orderings, multi-version concurrency control. Those are to ensure isolations. How about atomic cities and durabilities? Consistency, just you dictate whether the database is correct, which, let's say you write Python, just having a lot of emails, that's it. So not so hard, right? How about atomicity and durabilities? How does database management system ensure that they have both atomicities and durabilities properties? So let's talk about atomicity first. Atomicity means that, let's say if all the steps in a transaction is done, good, wonderful, we don't need anything. The problem is when it's done halfway, when some of the steps are done. If some of them are done, then we need to revert each step back. That's the point. Which means, in order to ensure atomicity, whenever you hit some halfway done situations and you need to roll back, you should be able to revert the effect of each step back. In order to do that, you should log every action. You should, when we say the word log is like a diary log that you write what happened each day. Wow. You write what happened each day on a book, right, on a diary, right? This one is the same thing. You write every single actions most of them will be on write and read, or whenever the values get updated. Whenever the values get updated, you log into a file that we update value A from 20 to 30. So if you would like to roll it back, you just need to read that log and then, oh, the value, we update the value A from 20 to 30, then if you want to roll back, then we just need to go back from 30 to 20. In database management system, most of them have something that we call write ahead locking, WAL, wall, right? Write ahead locking is basically this kind of lock. You lock every single updates on values, right? And sometimes you also lock the beginning of the transactions, whether the transaction gets rolled back or commits as well, right? The reason why it's called write ahead lock is that you try to write the actions down to the log ahead of the time before you actually update the values. So that is why write ahead log, you write ahead of the times before you actually perform the updates. Well, there's only text on this slide. I know that some of you may think that, oh, I don't understand. So I do some visualization. So let's say we have the transactions, this fancy transaction, right? You begin the transactions, then you try to read the X, right? And you write the X as it is A subtracted by 50, right? We comment it. Right hand log will be something like this. You can think about right hand log as a table as well. It doesn't need to be a table, but the information must be something like this. So, okay, now the value of X is 100. Okay? Just to give you a heads on, value of X here are likely going to be on catch. It's not on the list. Okay, so you begin transactions. So once you begin the transactions, you log in. Log. The first one is log sequence number. It's just a sequence number. It's just a running number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? The next one is the previous log sequence number, in which if there is previous steps, you're going to put the log sequence number of the previous step here. So that when you trace back, you know where to go back. In case that there are multiple transactions, then maybe log sequence number 2 could be for another transactions. Or something like that. So having this will allow you to trace back when you do your backing. The next one is the operation type. So mostly going to be begins, updates, commit, rollbacks, those kind of things. And the transaction here, we are working on transaction. Let's say this is a transaction A. So you put the transaction ID here. And then the last three fields, mostly you're gonna get filled when the updates happen. But we just begin, so no updates happen. Then you read. And this is something I would like to know that most of the times, you try to write the write ahead log whenever you update the data. Reading the data is basically not updating data, right? So you don't need to write, you don't need to log everything, every single action. Just need to log important action. Next one. Okay, yes, definitely, right? You write, right? So for transaction A, you write X before it's 100, after it's 50, right? And you now add the log sequence number 2. You put that, hey, the previous action for the same transaction is 1. So let's say if you want to go back, so you just need to, oh, it's the previous one is 1, you go back to the 1 to see what's going on. Okay? Then you come, oh. So once you write onto the log, don't forget to update the values as well. Again, it's write ahead log, so you need to log first before update the values. There is a reason why you need to log first. Okay? In which I will cover it later on in this lectures. Next one is comments. So you put comment on it, and that's it. Happy ending. So what if now we don't do commits you roll back. The first few one we're gonna do the same things, right? You update begins, you read it, you write it, you update it, right? And then now rollbacks happen, right? The up value get updated to 50s, right? Rollbacks happen. Whenever rollbacks happen, you read the write-ahead log. You read the latest entries of the write-ahead logs, and you revert the value back based on what you wrote in the log. For example, this one. Oh, now we are rolling back A, and this is the entry for transaction A. The value before is 100, so we're gonna roll it back to 100. And we check, go back to the previous entry for this transaction N. Oh, it's now N, right? Because we adapted the beginning of the transactions. So we stop rolling back. That's it. We call this process undo, right? Pretty straightforward. So try to undo the things. So whenever you get halfway done, undo it. Pretty simple, right? Any questions, comments on this? But now we only talk about the situation where we put rollbacks on it explicitly. But if you put rollbacks on it, then okay, it's easy to see whether how you're gonna roll it back, right? What if the computer just crashed without you putting the rollback explicitly? When you're gonna know? How are you gonna know when to roll back in? So we're gonna talk about some things more crucial to recover the system from a crash. So when crash, definitely some transaction may not be incomplete, but some may be complete. It should be let's say may not be complete. Okay, looks better. If transaction is not complete, atomic safety properties may not be whole. Durabilities also might not be whole, right? Because durabilities mean that all effects of the commit transaction must be persistent. Let's say you run all transactions and let's say it get commit, but those values may be cached on the cache, on the volatile memories, on DRAM, that whenever the system crash, your power off, those data are gone. Durability is not preserved in that case, right? Even though you commit the transactions, data are on the cache and before it gets flushed, before it gets into the checkpoint, your computer crashes first. So all the data are gone. So to solve it, one of those is don't do caching. Don't cache anything. If you don't cache anything, then whenever the system crash, you open it up, you read write-ahead log, and you undo incomplete transaction. That's it. You just reread the log and see which transaction doesn't have commits or doesn't have rollbacks, explicit rollbacks. Those transactions are not complete. You just undo them. Right? Simple, right? But the reason why we cache data, right? If we don't do caching, then it's gonna be slow. That's why we cache the data. So is there any better solutions that we can also do data caching? Why we also preserve durabilities and atomics? The idea is that why don't we just process only write-ahead logs? And we still cache data objects, that's fine. But write-ahead log, whenever we log the write-ahead log, we keep writing it on disk. You may say that, hey, if you always write on disk, it's gonna be slow, right? There's something like this. If you remember when we talk about data organization, we're talking about sequential access as well, right? All the logs here, you see that all the logs, mostly they're appends on a single table, right? So most of the time, the log here, when you write on the log, we kind of like write the data sequentially. So it's not, for this, if you read the specification of this, most of the list is gonna say that for sequential access, they're gonna be fast. For random access, yeah, that is the point that they're gonna be slow. So write the logs sequentially like this. Yeah, definitely it's not that fast, but it's not that slow as well. So that is why many database vendors they think that this they kind of like they decide to only purchase the write-ahead log, not purchase the data objects. Right. Then once now we have the log, it's basically the truth, right? All the actions you do. But the problem is that if we undo it directly, some data are on the cache, they're not flushed yet. So some of them should be reverted because the data somehow get updated on the cache, but the data that they process on this, it doesn't get updated yet. So we may need to perform something that we call redo first. So the crash recovery algorithm is basically you redo everything on the write-ahead logs first to make sure that we are at the current state before it gets crashed. Then you start undoing incomplete transactions. That's it. So just to write some outlines. So let's say this is time, right? This is, say we have transaction 1, transaction 2, transaction 3 here, right? So transaction 1 start here, and here, transaction 2 start here, and here, transaction 3 start here, and here. Let's say the crash happens here. The crash hits here. Somehow, the latest checkpoint is here. This is where checkpoint matters. Which means all the values before this point must be processed on this. But after this, there is no guarantee that the values that update in this transaction will get flushed on this. There is no guarantees on that, which means you may first need to make sure that you are at this stage first. So you redo everything from when it crashed here, right? But the log is also here as well. The right ahead log, right? Because you need to log first. Log is here, right? The right ahead log is here. So you revert everything. You redo everything since checkpoint to this time. Redo. First step. Then now, when you redo it, you're gonna see that, hey, this transaction, it's safe. It get committed. It's just transaction 2 and 3. And they are incomplete before the crash. They are incomplete during the crash. Which means we need to undo them. That's it. Actually, the naive redo and undo approach
this is not quite a good approach. This is an approach that it gives you correct answer. Sure. But someone say that doing undo directly like this sometimes can limit the concurrencies. Because let's say while you're doing redo undo, you shouldn't do anything else to ensure that the values doesn't get updated during this phase, during this very crucial phase. And someone say that if you do this, once you do redo undo, then you need to perhaps do everything since checkpoint. And let's say if your checkpoint is you're not doing checkpoint very often, you do checkpoint yesterday. You need to do everything since yesterday, the 1 day long transactions. Not that great, right? That's why there are other mechanisms as well. Aries. But we're not gonna cover it in this course, right? It's a little bit out of scope, right? But this is a very popular approach to recover, doing this in a more efficient way, right? Alternatively, rather than you use Aries, you can also do checkpoint more frequent, so that whenever you want to recover from a crash, you're not gonna do a lot of redo and undo. So checkpoint. Last year, checkpointing is one of the exam questions. I asked you that what is the benefit of do checkpoint frequently? And now you should know the answers, because you can reduce the crash recovery times, right? Okay. So I talk about everything already on these slides, right? You append checkpoint. Oh, the checkpoint will be on the log as well, so that you know what is the latest checkpoint. Okay, and you find a checkpoint, then you redo by each entries by updating values according to the after. Like you redo first, then you also should keep track of which transactions, or when each transaction begins and commits rollback, because you want to know, you want to undo only the transactions that are incomplete. You don't want to you don't want to undo transaction that are already complete. Right? Okay, then you undo it. And yeah, frequent checkpointing fast recovery. Right? Since I told you straight away like this, which means they're not going to be in the final exam. This questions, okay? Last year, yes, it was in, but this year, this won't be an exam question. That's it. Wow, very fast. So, right ahead logging is basically the key to atomicity and durabilities. That's it. That's what I want to say. It is a very important thing in database management system. So, since this is the last lectures, just want to give some parting thoughts that, back then, when we first started this class, we talk about data. We talk about how important data is, right? Data is basically for you to make a better decisions. Better here means more precise decisions, more accurate decisions, right? And given more accurate decisions, you are likely to gain more beneficial insight, more realistic insights. And having these good insights allowing you to kind of like make some new innovations and craft new solutions. If you have old insight, if you have the same insight as the others, more of the solution will be the same things. But if you have some secret sauce, some new insight that you or only a small group of people know, then you're likely gonna get new solutions and innovations. And to get insight fast. Good data management is your friends, right? And in this class, the reason why I try to break the topic down to data caching, blah, 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 I didn't talk about data caching specifically for database management system is because data caching doesn't need to be in the database management system. You can implement data caching by yourself, right? In your own application without using database management system. Data persistence as well, right? Some data redundancies as well. Data not redundancy. You shouldn't have redundant data. But to make sure that the data are not redundant, you should try to do it, right? Your applications, right? Including this one as well. Even though I talk about transactions, but the crash recoveries, the write-ahead loggings, you don't need to use it with only DBMS transactions. You can use it in maybe your own sets of action, your applications, something like that. Yeah, that's it. Oh, no, we have a quiz. So this is the last quiz, okay? So let's me stop the recordings.